Number 13 on the EOC Algebra 2 practice test. A person's batting average is determined by dividing the number of hits by the number at bats. William has 11 hits in 53 bats and has a batting average of .208. He wants to have a batting average of at least .3. Which equation could be used to determine X, the number of hits in a row William needs to get in order to have a batting average of at least .3? All right, so when we look at our choices here, we see that each one of these has .3 and it has less than or equal to. So the part on the left, we don't have to worry about. So up here it says a batting average is divided by the number of hits by bats. So we know that to begin with, we have 11 over 53, and his current batting average is .208. All right, what we're trying to do is determine which one of these inequalities would help him get to a .3, so we can determine how many bats he needs, or how many hits he needs when he's up at bat to get this batting average. All right, so if you look at the first one, it says 11 times X. So that's 11 times the number of times he hits, so that one doesn't make sense at all. All right, this one is putting the X times the batting average, so this one doesn't make sense either because it's not changing the number of times he hits. All right, and this one is saying that, okay, he hit 11 times out of 53 to bat, and we're going to add another hit. Well, we do want to add however many hits we need, but if we add the number of hits, it's also going to add the total number of times at bat. So the only one that makes sense in this one is D. All right, so we're going to use part D, and we're going to use that, and we're going to look at part B. All right, so if I scroll down to part B here, we know that we're going to use equation or inequality D. We're going to think of it kind of as an equation because, you know, it's going to equal or be greater than that. So we need it to at least be equal to that. So what I'm going to do is say, how many hits in a row after his 53rd time at bat would William have to hit in order to have a batting average of .3? So if I look at this, I'm going to have .3, and I'm going to look at it as an equation for right now because, like I said, it's got to be at least equal to. It may be greater than, but we need it to be at least equal to, and we're more familiar with working with equations. All right, so take this, and then we can put this over 1. And when we put that over 1, then we can just cross multiply. And we cross multiply, we're going to have .3 times 53 plus X. And that's going to equal 1 times 11 plus X, which is just 11 plus X. All right, now if you take the .3 times 53, you're going to get 15.9. And then .3 times X is just plus .3X. Now I'm trying to solve for X, so I need to get X on the same side. So I'm going to subtract the .3x, and I'm going to skip over the words here and bring this down. So this will cancel, and I've got 15.9. This cancels, so that equals 11. And then this is just 1. It doesn't have a number here, so there's no coefficient. You assume it to be a 1. So 1 minus .3 gives me 0.7, and I know that's a positive 0.7x. All right, now subtract 11 from both sides. And 15.9 minus 11 is 4.9. and that equals 0.7. And then divide both sides by 0.7. 49 divided by 7, the same as 4.9 divided by 0.7 is 7. So it says how many hits in a row after his first 53 times at bat would William have to hit in order to have a batting average of exactly 0.3. Since X was the number of times we added bats and we solved for X, that means 7 is your answer.